Fine, go ahead.
No, you bring it after.
Welcome to 4.3 Notes with Miss Stewart. Just kidding. Okay.
Oh, come on.
Okay. So, here we go. I've got about 5 of you all in here, so it's a little weird. I'm going to show you some examples from section 4.3. Shh. Stop, please. All right. First, we're going to do example 10. This is number 10 in the book. Shh. All right, I've got a right triangle. Here's theta. That's 18, and that's 12. So the directions say find the exact value of the 6 trig functions for the angle theta shown. Use the Pythagorean theorem to find the third side. So we need to know what this side is. That is your hypotenuse. So a squared plus b squared equals c squared. I think 18 squared is 364. 324. So add those up. That's not a perfect square, I don't think. Let's double check it, because if it is, it's going to save us a lot of work. Okay, so we checked to see if it was a perfect square, and it's not. So it said, said a little word in here in the directions, exact. So we are not able to get it as a decimal. We have got to break it apart. Simplest radical form. I think 4 goes into it. So we'll do 4 and 1, 1, 7. 117 breaks down with a 3, 30, 9. 4 breaks down 2 and 2. And 39 is 3 and 13. So these are our primes. So I've got a pair of 2s to come on the outside, another pair of 3s to come on the outside, with that 13, that was a 3, with the 13 left over. So it's 6 square root of 13. So I'm just going to erase that x. We found that value now, 6 square root of 13. Okay, so let me erase the top. And we want the sine of theta, all 6 trig functions, cosine of theta, tangent of theta. Remember the reciprocals, everyone gets a every pair gets a so we have our cotangent. Cosine already has the so it goes with plane secant. Sine doesn't have a so it needs cosecant. And let's do sine first. So label this like you did on the Headless Horseman sheet with your hypotenuse first. Hypotenuse first. Theta is the angle for this problem, so 18 is opposite and 12 is adjacent. So sine is SOHCAHTOA, so sine is 18 over 6 square root of 13. Oh, we are not allowed to leave a radical in the denominator. And right here, 18 over 6 is 3. So we're going to reduce that, and we're going to rationalize. So that's going to give 3 square root of 13 over 13. That might have been too much to do all at once there. I'll do cosine a little. I'll take more time on cosine. So cosine is adjacent over hypotenuse. Let me just scoot tangent and cotangent out of the way. We need to rationalize. That's 12 square root of 13 over 6 times 13. And 12 over 6 is 2 over 1. So that's 2 square root of 13 over 13. Tangent, I had to scoot out of the way. But tangent of theta is O over A. Divided by 6 on both is 3/2. Now I'm going to get rid of my triangle here. And I'll scoot down cosecant and secant. I'm going to give you a trick. If you're paying attention, you will appreciate this. When you want to get cosecant, you know it's the reciprocal of sine. I'm going to say go back to this before you rationalized it and just flip it there. So you've got 6 square root of 13 over 18, and 6 over 18 is 1/3. So it's a square root of 13 over 3. That's that answer. Secant, again, if you had to rationalize to get your final answer, go back to the step before you rationalized. That way you don't have to rationalize again. So it's 6 square root of 13 over 12, and 6/12 will be square root of 13 over 2. Tangent, we didn't have to rationalize, so cotangent's just a reciprocal. Okay, the next set of problems that you're going to do is 13 through 20, so I'm going to go ahead and do 14 for you. And it says the cotangent of theta is 5. So you're going to sketch a right triangle corresponding to the trig function of the acute angle. Use Pythagorean theorem to determine the third side. So let's sketch just some random right triangle and just place theta as one of those acute angles. So it says the cotangent of theta is 5. Well, I'd like to see that as a fraction. And then I immediately know what the tangent of theta is because it's reciprocal. So you've got the hypotenuse, you have the opposite, and you have the adjacent. So tangent is opposite over adjacent. So we just need to figure out that side right there. So a squared plus b squared is c squared. Finish up your Pythagorean theorem. Take the square root of both sides. 26 breaks down to 2 and 13, no pairs, so we will leave it square root of 26 for that missing side right there. And then let's read the directions again. They want us to sketch the right triangle that goes with this information. I think we're done. Last one I need to show you is 21 through 30. Let's just do, let's do 24. Bless you. 24, we have some blanks we need to fill in. We've got function, theta in degrees, theta in radians, and function value. And on 24, they're talking about secant. And the radian measure is pi over 4. Well, I hope by now you know that pi over 4 is 45, so we've got that for degree. And function value, I'm going to my unit circle. Take a picture of it real quick. And we're talking about pi over 4, which is that square root of 2 over 2, comma, square root of 2 over 2. So let me write that down so I can look at it. Okay, I want to know what the secant of theta is. Well, secant's not immediately obvious on the unit circle, but cosine is, and they are reciprocals. So this is the cosine of theta. And secant of theta would just be the reciprocal. We're just going to flip it. We ended up with the square root in the denominator, so we need to rationalize. So it is 2 square root of 2 over 2, and 2 over 2 goes away for just a 1. So the function value for theta is square root of 2.